So our first example is solve the equation 2 raised to the power of x is equal to 53. So if you want to solve this, the first step is let's write it down. Whenever you have this 2 power x is equal to 53. So after we write it down, the next step, whenever you have like this kind of indices from like a number raised to the power of unknown x, so take log of both sides. Take log with base 10 of both sides. So, and this is will just be log. Since it is base 10, I can just write it as log 2 raised to the power of x is equal to log 53. Then after we write it like this, we should remember the rules that if you have a log of any number raised to the power of n, this is just, you can just take this n back, n log a. So this is for any base that you have, any base. So since the base is 10 is a base, so here this x is just like our n, 2 power x. So we can just take this x back. So it will become x log 2 is equal to log 53. Now we want to find this x. So our problem here is to remove this log 2 here so that we'll just have x alone. So we'll just divide both sides by log 2 since we have x times log 2. So we'll have x log 2, this side divided by log 2, and here we'll have log 53 divided by log 2. And if you look at here, log 2 goes into log 2 just once. So we'll just have 1x, which is just x is equal to log 53 divided by log 2. And if you can put in the calculator, log 53, we will get 1.7243 approximately, and log 2 will be 0.301. And if you divide this, you will get 5.7286. And that's all. So now we want to solve the equation log of x plus 56 base 4 is equal to 5. So the first thing, whenever you are given log of something with unknown, try to write it in the indices form. So remember that whenever we have a log of with base b of some n, whatever it is, raised to power p, this in the indices form is just we write it as this b, our base, raised to power this p power is equal to n. So let's look at our problem. Our problem, we have log of x plus 56 equal 5 base 4. So if you look at here, this is our b base, this is our n. So this, let me highlight it. So this is our n, and this is our power, this is our p. So this we can just write it as our base 4 and our power, which is 5, is equal to x plus 56. Now this one we can just write it as 4 raised to the power 5, which is just 4 times 4 times 4 times 4 times 4, that is 5 times, is equal to x plus 56. And this is 4 times 4 times 4 times 4 times 4. This is almost 1024. So, and this is x plus 56. Now we want to find x. We have 56 here, so we should remove 56 from both sides. So we'll have this, then we say minus 56 is equal to x plus 56 minus 56 here. Then from here we'll have a 1024 minus 56. This will give us 968, and this will give us x. 56 minus 56 is 0, so we have 968 is equal to x, or we can just write x is equal to 968. So we want to solve the equation exponential 2x equal to 7. And whenever you are given something with exponential something, so instead of taking the log of both sides with log with base 10, so we'll take the natural log, that is ln, the log e of both sides. So let's write it first. Exponential 2x equal to 7. Then we'll take log e of both sides. So this will be log e of this e raised to the power of 2x is equal to log e of 7. But remember, we have a rule that whenever we have a log of anything, whatever the base is, whether it is e or whatever, of a raised to the power n, this is, we can just take n behind, n log uh, n log a with this base b. So we just take n behind log. So we will do the same here. We'll take 2x here, so we'll have 2x log e base e is equal to log 7 base e. And remember, we also have a rule that whenever you have log of something, maybe whether it is e or b, and they are the same, is equal to 1. When the result and UIB, what you are taking log of, and UI base is the same, is always equal to 1. So this will just implies 2x times 1 is equal to log e7. And from here we'll have a 2x times 1 is just 2x is equal to log of base e7. And just remember, just log e is just the same as ln, so I can just write it as ln 7. And this will just imply that we should, since we want to find x, we can divide both sides by 2. So we'll have 2x divided by 2 is equal to ln 7 over 2. So 2 will goes into 2 once, so we'll have 1x, which is just x, is equal to ln 7 over 2. So ln of 7 divided by 2. And this ln 7, if you use calculator to compute it, ln of 7 is just 1.9459 divided by 2. And if you divide this by by 2, you will get, I think, 0.972, maybe approximately, maybe 96, something like this. So in this problem, we want to solve the equation 3 ln x plus 1 is equal to 12. Let's write it down first. 3 ln x plus 1 equals 12. So let's have only ln at this side, so we just should kind of divide both sides by 3. So we'll have a, let me split it in this into 2. We'll have a 3 ln x plus 1 is equal to 12. We divide this side by 3, this side by 3. 3 goes into 3 just once, so we'll have 1 ln x plus 1, which will just be ln x plus 1. 1 times anything is just that thing. 12, 1 times any number is just the number. So 12 divided by 3 will just give us 4. Now, whenever you have this form, the next thing to do is just try to write this as in form of exponential. But in order to write this, since this is ln, let's write it in log so that we'll be able to write it in the exponential form. So it is just log e of x plus 1, because ln is the same as log e. So these two are the same. So then we just write it, this equals 4. And remember, if you have a a raised to the power of n equal to, sorry, if you have log of any base with some number equal to p, this implies this b raised to the power of p equal to n. So in this case, we have a this is our base, this is our p, this is our power. So we can just say e raised to the power of 4 is equal to x plus 1. And let me write it down here again. So e power 4 equal to x plus 1. And what we want to find is x. So we can just subtract 1 from both sides. So we can just say e4 minus 1 is equal to x plus 1. Then we subtract it here. So we have e4 minus 1 is equal to x1 minus 1 is just 0. So we'll just have x here. And this can be written also as e4 minus 1. And this e raised to the power of 4, if we compute it, we'll get this is equal to x will just be equal to 54.598 minus 1. And this just equal to, I think, this just equal to minus 1, so it will be 53.598.